Dear students, good morning. In the last lecture, we have seen the concept of B tree as well as the concept of B plus tree. Also, we have gone through an example which is based on B tree and B plus tree. Now, today again we will have several examples which is based on B tree and B plus tree. Let us take first example. Construct B tree of order 3 and key values which we have given are like 7, 6, 1, 4, 9, 3, 12, 10. We have given order equal to 3. Therefore, in this case, the value of m is 3. Okay, now as we know, we have given order m equal to 3. Therefore, a node can have maximum number of keys equal to m minus 1. That is, a node can have maximum number of keys equal to 2. And if a node has number of no keys equal to 2, if number of keys in a node equal to 2, then it has number of children equal to 3. Okay, now let us solve this example. So first I pick up first key 7, I create a node and data it becomes 7. Second 6, as we know, when we are adding the key, we have to add the key in such a way that the key values inside a node should be in the ascending order. Therefore, when we add 6, key values becomes 6, 7. Next, in third step, next key value is 1. Again, as I add 1, it becomes 1, 6, 7. But we know the capacity of node is 2. Now there are 3 keys. Therefore, there is, we can say there is overflow. We pick up the central key value which is 6. We create new node which is having data as central data. It becomes 6. Therefore, we create new node whose data equal to 6. Now 1 is added at the left hand side of 6 and 7 is added at the right hand side of 6. Next, in the fourth step, next key value is 4. As we know, 4 is less than 6, therefore it is added at the left hand side. At the left hand side, there is only one key in a node 1, and when I add 4, it becomes 1, 4. Therefore, left of 6 it becomes 1, 4. Right of 6 becomes 7. Next is 9. Again, we compare 9 with 6. 9 is greater, therefore it is added at the right hand side. Therefore, at the right hand side there is only one key value 7. As we add 9, it becomes 7, 9. Therefore, right of 6 it becomes 7, 9. Next key value is 3. 3 is less than 6, therefore it is added at the left hand side. As I add 3 at the left hand side, it becomes 1, 3, 4. Because as we are adding new key value, we are arranging data inside node in such a way that all keys are in the ascending order. Therefore, as I add 3, the node data it becomes 1, 3, 4. Previous it was 1, 4. As I add 3, it becomes 1, 3, 4. Okay, but the capacity of node is 3, therefore there is overflow. As there is overflow, we pick up the central node, a central key value which is 3, and we shift it to upper node. Upper node is 6. there is one more space, therefore uh, as 3 gets shifted to its upper and it becomes now 3 6. Now left of 3 becomes 1, right of 3 becomes 4, and right of 6 becomes 7 9. Next is 12. Again 12 is greater than 6, it is added at the right hand side of 6. As it is added to the right hand side of 6, it becomes 7 9 12. Again there is overflow, again we pick up the central key value 9 and we shift it to its upper node. It becomes now 3 6 9. Again there is overflow because the capacity of each node is 2, but 3 6 9, that is there are 3 key values, therefore again we pick up this central node, a central key value, we create a new node whose data equal to that central data. So it becomes 6, left of 6 becomes 3, right of 6 becomes 9, left of 3 becomes 1, right of 3 becomes 4, left of 9 becomes 7, right of 9 becomes 12. Next is nothing but 10. As we know 10 is greater than 6, it is added at the right hand side. Again it is greater than 9, again it is added at the right hand side. Right hand side of 9 contains only one key value 12, so we can add one more, that is upcoming is 10, so it becomes 10 12. So this is the final B tree. 6 is the root node, left of 6 becomes 3, right of 6 becomes 9, left of 3 becomes 1, right of 3 becomes 4, left of 9 becomes 7, right of 9 becomes 10 comma 12. As at every step we are satisfying the properties of B tree. Once again I would like to revise what do you mean by B tree. B tree is M ordered search tree. B tree is M ordered search tree in which every node can have maximum m minus 1 keys, and if a node has m minus 1 keys, it is having number of children equal to m. All keys are at the same depth. In this case we have given order m equal to 3, m minus 1 equal to, now we calculate m minus 1 which is equal to 2, that is capacity of each node is 2, and if a node has m minus 1, that is if a node has 2 kids, it must have number of children equal to 3. So in this example we are satisfying all the properties of B tree. Next, let us solve now this example for the same key values, and let us try to construct B plus tree. Okay, we have given suppose same key values, and suppose now I would like to construct B plus tree. So let us solve this example. Okay, same key values we have given, and the problem is construct B plus tree of order 3, and the key values which we have given are 7 6 1 4 9 3 12 10. We have given order as 3, therefore m equal to 3. Now let us solve this example. Yesterday we already have seen the difference between B tree and B plus T. Actually B plus T is the variation of B tree. The major difference between B tree and B plus tree is that in B plus tree all leaf nodes are linked togetherly. In B tree we do not link all leaf nodes but in b plus t we have to link all those leaf nodes. Okay, now let us solve this example by taking one by one key values. First is 7. Okay, as we have given order equal to 3, therefore each node is has capacity to store number of keys equal to 2. Okay, first is 7. 7 it get added as it is. Next one is 6. Here also in b plus t all keys should be arranged in the ascending order, so as I add 6 it becomes 6 7. Next is 1. As 1 get added it becomes 1 6 7. Now a node is having number of keys equal to 3. Therefore there is overflow. Now we pick up this central key value which is 6. We create a new node which is having data as central data. Now it becomes 6. Now as I create new node which is having central data 6, now left of 6 it becomes not only just 1. Now left of 6 it becomes 1 comma 6 and right of 6 it becomes 7. See, while constructing b tree, okay, when there is overflow, left of 6 it becomes 1 and right of 6 it becomes 7. But in b plus tree, left of 6 it becomes 1 as well as 6 and right of 6 it becomes 7. Next, in fourth step, next is 4. As 4 is less than 6 it is added at the left hand side of 6, so it becomes now 1 4 6. Again there is overflow, therefore we pick up this central node which is 4 and it we shift it to its upper node, so it becomes 4 6. Now left of 4 it becomes 1 comma 4, right of 4 it becomes 6 and right of 6 it becomes 7. Once again I repeat, 1 4 6. There is overflow, we shift 4 which is central key to its upper node, so upper node becomes 4 comma 6. Left of 4 it becomes 1 comma 4, right of 4 it becomes 6, right of 6 it becomes 7. Okay, and see here I have linked all the leaves by using pointer. Next is 9. As 9 is greater than 6 it is added at the right hand side of 6, therefore it becomes 7 9. 4 comma 6, then 9 comes, 9 is greater than 6, therefore it is added at the right hand side of 6, therefore it becomes 7 comma 9. Next one is 3. As we know 3 is less than 4, therefore 3 is added at the left hand side of 4, therefore it becomes 1 3 4. Again there is overflow, therefore we pick up the central node which is 3 and we shift it to its upper node, so it becomes 3 4 6. Again 3 4 6 there is overflow, so I pick up this central node which is 4, central key which is 4. I create new node which is having central data as 4. Left of 4 becomes 3, right of 4 become 6. But while writing left of 4, please do not write 3 comma 4 as it is not leaf node. Once again I repeat, as 3 come, 3 is less than 4, therefore it is added at the left hand side of 4, so it becomes 1 3 4. Now there is overflow, so central key which is 3 shifted to its upper node. So as I shift 3 to its upper node, it becomes 3 4 6 3 4 6. Again there is overflow. Again I shift central key which is 4. I create a new node which is having central data 4. Left of 4 becomes 3, right of 4 becomes 6, and left of 3 it becomes 1 comma 3, right of 3 becomes 4, left of 6 becomes 6, right of 6 becomes 7 comma 9. Next 12, as 12 is greater than 4, it is added at the right hand side. Again it is greater than 6, again it is added at the right hand side, so it becomes 7 9 12. Again the capacity is 2, there is overflow, therefore we shift 9 to its upper node. So 9 gets shifted to its upper node and it becomes 6 comma 9. Next is 10. Okay, next is, sorry, when 12 comes, 12 is greater than 4, it is added at the right hand side of 4. Again it is greater than 6, again it is added at the right hand side of 6. So therefore it becomes 7 9 12. There is overflow because the capacity of each node is 2, but there are 3 keys, therefore I shift 9 to its upper node. So tree becomes like this: 6 comma 9, left of 6 becomes 6 as it is, right of 6 becomes 7 comma 9, and right of 9 becomes 12. 9 goes to its upper node, therefore it becomes 6 9. Now left of 6 becomes 6 as it is. Now right of 6 becomes not only 7 but it is 7 comma 9, and right of 9 it becomes 12. Next is 10. As 10 is greater than 4, it is added at the right hand side. Again it is greater than 9, therefore um, uh, it becomes 10 comma 12. So this is the B plus tree. In each step here we are following all the properties of B plus tree. B plus tree is a variation of B tree in which every in which we are connecting all leaf nodes togetherly. In this way we can solve so many examples in which we have given number of keys and we have given particular order M, and uh, as now we already are well familiar with how to construct B tree and B plus tree. Thank you.